adding or subtracting rational expressions. Number one, factor the numerators and denominators of both expressions if possible. Identify the non-principal values. Determine the lowest common denominator. Multiply the numerator and denominator by the missing factors. Distribute the numerators. Add or subtract the numerators and keep the denominator the way it is. And then simplify. There's quite a few steps, but the best way is to not memorize steps, but just do enough questions that this becomes part of your being. Okay? So when we start off, it's not that hard because we start off with basic ones. So we're basically starting off where we have monomial numbers in the bottom. So they're a little bit easier. And we also start off with ones with common denominators already. The only way you can add and subtract fractions or rationals is common denominators. So we're going to look at example 1. Simplify 2x over 3 minus x over 3. So they're both over 3. So because they're over 3, I can actually just subtract them right away. What do you do when you subtract fractions? So say I have 3/4 minus 1/4. The reason why you get a common denominator is because when you subtract them, you keep that denominator, right? So 3/4 minus 1/4 of a pizza, you still have half of the pizza left. Or say you had 4/4 of a pizza, so a whole pizza. You subtract off 1/4, you have 3/4 left, right? So the reason why you get a common denominator is because you keep that denominator. So when some people do try and subtract them, then what was the point of getting a common denominator in the first place? So because these are both over 3, our answer is going to be over 3. Once we get a common denominator, we can just put our numerators together. So technically, we have 2x subtract x all over 3. We don't have to take any non-principal values for this question because there's no variables in the bottom in the denominator, right? So there aren't any non-principal values for this. Draw our numerator together, 2x minus x. What's 2x's minus 1x? Like 2 apples minus 1 apple. 1. So just 1x. And you try x, or you can write 1x, neither of which is incorrect. I think 1 over 1 in front of the I don't understand any restrictions because I put a 3 in the bottom. So the reason why we get a common denominator is once we get that common denominator, our answer is going to have that as the denominator. That's the point of getting it, right? Or else you're wasting it. So here I have 2a minus 3 over 5 plus 9a plus 1 over 5. So because they're both over 5, I can just write the whole thing over 5. I put my numerators together. Now, 2a minus 3 plus 9a plus 1. You don't have to have the 9a plus 1 in brackets because when you add two terms, like technically we're adding 9a and we're adding 1. When we add two terms, we don't have to put it in brackets because when you add, it doesn't change the sign, right? When we subtract, we have to watch ourselves. We'd be subtracting the whole thing. So when we subtract a binomial or more than one term, we have to remember to put in brackets. But adding, we're okay. We don't have to do that. So now, once we have them all over 5, we can just collect the like terms on the top, even numerator. So on the bottom we have 5. That doesn't change. Once we get a common denominator, that will be our denominator. Then we can get common terms together. So now we have 2a plus 9a is 11a minus 3 plus 1. What's negative 3 plus 1? Negative 2. 11a minus 2, I can't take anything out of that. So technically you have this, 11a minus 2 over 5. Can I simplify anything out of that? No, it's done. You can always check at the end. Maybe you can take a GCF out and cancel something off, right? That's your last step. Show what you're adding. But for the most part, I'm just going to say, do I have to have that 11a minus 2 in brackets? No, I'm just proving the point. It's in brackets. The 5's in brackets. They don't match. You don't need to have it in brackets. Now this one's over 4. Both of them are over 4. So we can write the whole denominator over 4 because we have a common denominator of 4. Then we can just write the numerators. 3x plus x. Still don't have any non-principal values because the denominator doesn't have a variable in it. What's 3x's plus 1x? 4x. Now, what's my catch on this one? The 4 is in brackets, the x is in brackets, the 4 is in brackets. What could I actually do? Cancel those 4's off, right? So 4x over x isn't wrong, or sorry, 4x over 4 isn't wrong, but it's not in simplest terms, so the answer won't be there. The answer x, however, will. X over 1 is not incorrect, but it won't be there either, just the x will be there. But x over 1 isn't wrong. If it was a written response and you had that, I couldn't mess it up. D, this is where I get errors all the time. So, all over 6, you have a common denominator. But the catch here is 5y minus 1 minus 4y plus 7. Everyone writes it like this. And you're like, yeah, okay, so what's wrong with that? You write it like this, which is the common error that everyone does. You're only subtracting the 4y. You're not subtracting the 7, are you? This is 5y minus 1 minus 4x plus 7. We're minusing the whole 4x plus 7. So we have to remember that we're minusing the whole, I guess 4y plus 7, I don't know what I'm saying. The whole 4y plus 7. So we have to remember that when we have more than one term, so binomial or trinomial behind that minus sign, we have to bracket because we're subtracting the whole thing. So a lot of people like skipping this next step, but I do it so that I don't get it wrong every single time. So now, in order to get rid of this minus, or this bracket, I can actually just distribute the minus in, right? This is like having a negative 1 in front, technically. So I can distribute that negative 1 in and change those signs, and then I'm done. And the bracket can go away. So 5y minus 1 minus 4y minus 7 over 6. Now I've actually subtracted both of those terms. Do you see how people could just make an oopsie and forget to bracket that? That common error will be the top common error in the diploma pick. They will have that answer there. They'll have the answer there for if you forget to bracket it, because that will be the number one oopsie. Okay? Now we collect those terms. 5y minus 4y is y. If you're someone who would have forgot those brackets, what do you do on your notes? Because they're your notes. And your notes are allowed to use a handle. So you want your notes in best form to possibly have them in. You would leave yourself a star and say, hey, don't forget brackets after subtraction. You give yourself little stars, little notes. You can highlight it. Okay? They're your notes. If you choose not to write stuff, then that's why. If you also just choose to put a star, but don't say why, I promise you can go back to your notes and be like, this is important, but I cannot remember why it's important. I wrote star here for a reason, but what's that reason? I don't know. So leave yourself a note. They're your notes. In university, you're the only one who's going to have your notes. No one's going to be like, make sure you put a star, and you have to be able to make the best notes for you, okay? Now, 5y minus 4y is y. And then negative 1 minus 7 is negative 8 over 6. So I have y minus 8 over 6. I know 3, it doesn't really matter. Y minus 8 over 6. Can I cross off the 8 and the 6? No. Remember, this is y minus 8. The only way it's going somewhere is if I have a y minus 8 on the bottom. Do I? No. This is good as dead. Like I said, people will get to this point and you'll do all this work and then you feel like it needs to be more simple. Don't be that person. Stop yourself. Okay? That's why I see the most errors. It's not, you don't know what you're doing, you just keep going. So stop. You don't know where to stop. An addiction. Math addiction. Okay? What's the difference with example 2 than what I have with example 1? I don't have the same denominator, so I need to make the same denominator. So, a lot of people think, what can I divide them by? Or no, you're going to multiply always. You're always going to multiply to make common denominators. So what can I make 4 and 3 be that if I multiply something by each of them that I could get a common denominator? What common denominator can I make them have? 12. I can make them both have 12. 24, yes I could. You can still do 24, but then you're going to be simplifying in your last step because you're going to have too much. So it's best to make it be your lowest common denominator, not just your common denominator. Okay? So my RCD, my lowest common denominator, this one is 12. And so that's what I'm going to try and make them be ultimately. Now, what people do is they do stuff based on sex. I don't want you doing something based on sex. I want you doing something based on knowledge. You know why you're doing this. So what do I have to multiply 4 by to get 12? 3. So I Everyone's good with that. They go multiply this by 3 and they're like, see, I have a common denominator. But you do the bottom, you have to do the top. Now, that's just a rule. Why is it? Why do we have to do that? What is 3 divided by 3? 1. When I multiply anything by 1, does it change that? No. If I multiply this by just a 3 on the bottom, would it change the whole thing? Yeah, you'd be multiplying by 1/3. That totally changes the equation. So that's what you have to do to the top and the bottom. Because if you do it to the top and the bottom, 3 divided by 3 is 1. You're not changing anything. If you do it to just the bottom, you're actually indirectly multiplying it by 1/3, which is totally different. So that's why you do it to the top and the bottom. Not just fixed rule, but because it makes sense. Okay? Then we have minus x over 3. And what are we going to multiply this by? 4. And I do to the bottom and I do to the top. Because 4 divided by 4 technically is 1. I'm not changing it. Okay? Pay any attention because you're going to be doing the next two. So 3 times 3x, 9x. 3 times 4, 12. Minus 4 times x, 4x. 3 times 4, 12. Now we're actually back to where we were before, right? Common denominator. What do I do when I have a common denominator? Right over that denominator. It equals 12. 9x minus 4x. Plus like terms, they are like terms. What's 9x minus 4x? It's like having 9 apples minus 4 apples. 5x. And no non-permissible values or restrictions because there's 12 on the bottom. 12 can never be 0. You only have to say restrictions or NCDs when you actually have a variable on the bottom, right? Okay, I want you guys to try B. Remember that when you make a common denominator between these two, you have to times that number, whatever you pick in the front, to both of these terms, right? 6 times by 3 and minus. So try out with B. You get ahead and you feel like you're dropping, try C. Remember, just, I know pencil sucks because you rub your hands rubs on it stuff, but if you're like trying something out for the first time and you don't know if you're doing it right, don't do it in pen unless you have like whiteout. If you have whiteout, then go for it. You'll run out of room. So try out B. If you're like, I got this, you can try C as well. Yes. Alright. So we said 6 is the lowest common denominator. We're going to multiply this by 2 over 2. So 3a minus 1, 2 times 3, plus 4a plus 5 over 6. Then we remember to trade the 2 in. We get 6a minus 2 over 6 plus 4a plus 5 over 6. Now we come to denominator, so you can write them over 6. So I get 6a minus 2 plus 4a plus 5. So I've done the 4a plus 5 in bracket. No, because it's an addition, right? It's a subtraction of half. Now I can plus by term. 6a plus 4a equals 10a. Negative 2 plus 5, positive 3 over 6. If you're someone who thinks you're going to cross that 10 and that 6 off and the 3 and the 6 off, bracket. The moment you bracket those, because they have a plus sign between, you know that the only way 10a plus 3 is going anywhere is if there's a 10a plus 3 on the bottom. And there isn't. There's 0 left. We're done. 8 and 3. 8 and 3, what's common to 8 and 3? Anyone? 8, 3. 24. So, that's the smallest that you can make. So this one I'm going to multiply by 3. Minus this one I'm going to multiply by 8. So, Mitchell, what do I do? What is it? Yeah. you have to go 3 times 8y, and then 3 times 3. Yeah. So all over 24, right? So you get 3 times 8y, which is 24y. 3 times 3, which is 9, minus 9. Minus over 24. 8 times 2y, which is 16y. 8 times positive 1, which is positive 8. And we have to remember to minus both of those off. So we get it all over 24. And then we're going to get 24y minus 9 minus 16y plus 8. Remember to distribute that minus sign in. 24y minus 9 minus 16y minus 8 over 24. Then you put, no. Come on. Then you can correct by term. So 24y minus 16y is 8y. Negative 9 minus 8, negative 17 over 24. There's nothing you can take out of 8y and minus 17. Minus 17 is a prime number, actually 17. So, only you take out the 1 or 17, 8 doesn't have either. Well, 1 is useful. So we're left with 8y minus 17 for 24. That is per here. Do not take the 8 and the 24 and cancel them. Please, please, please. Thank you. Stop it. If something's like, please stop. Okay? Here's someone who is an avid extra canceller. If you are, there's some of you out there. Make sure you're a bracketer then. If you bracket it, I promise you, you will stop canceling. Okay? Next page. Now we're actually getting into rationals more so because they actually have variables. So we look at rationals that have common denominators first. They're all over x, so we can make them all over x. If our denominator is just x, my NPV is x can't equal 0. There's some of you who think x can't equal 0 is an NPV for every single example. That's not the case. The only time it's an NPV is when you have just an x or an x squared or an x cubed or an x4 all by itself. It's not always an NPV. Some of you are go to, you put a 0 instantly. It's not always there. You get questions wrong if you do that. So please stop. So 2 plus 7 minus 1 is what's on the top, so we can write all over x. And then we plot like terms. 2 plus 7 is 9, minus 1 is 8 over x. And then we fall behind the x again. B is all over 2a. We have 2, which can't be 0. Don't worry about it. And then a can't be 0. So my NPV for this is a cannot equal 0. It will not be 0 for either of these two. Then we can get common denominator. We can just write 5a plus 3 plus a minus 6 equal. That's left our term. 5a plus a 6a plus 3 minus 6. I have 3 positives. I have 6 negatives. So you're going to end up with 3 negatives over 2a. There's something else I could do. And the numerator looks like take out. Starts with a T, rhymes with tree. But it's not tree. Tree. They just say starts with T, rhymes with tree, and they're like, tree. No, that's your number. 3, yes. And you're like, yeah, that's great. However, it doesn't cancel anything else. It doesn't matter. It said simplified. So you still need to take that 3 out. I can't cancel anything from here. It's not like it's going to make great strides, but it isn't simplified enough. So it's not like something cancels off or anything. Now like the bottom 2a crosses off with the 2a in brackets. Remember 2a minus 1 is only going somewhere if there is a 2a minus 1 on the bottom. Is there a 2a minus 1 on the denominator? No. Everything's staying, okay? Brackets, people, brackets. Brackets make life so much better, okay? Try C and D. So, we need 3y minus 1 in the denominator. If I want to do my NPVs, it'd be 3y minus 1 times that equals 0. I always label them so that they're easier for me to find. Add the 1 over, you get 3y times equal 1. Then divide by the 3, so y times equal a third. Once I've done that, I can write my numerator. So 3y minus 1. I could put this minus 1 in brackets. It's not going to make a difference. It's just one term, right? It's really, you need to remember brackets when this is two terms, so binomial or trinomial, more than one. Okay? 3y minus 1, 3y minus 1 are both in brackets, and they are matching twins. One goes through them. Whenever you cancel, like, when you started doing canceling in like grade 8 and 9, when you cancel, you're actually making a 1. Like this divided by this is a 1. So every time you cancel and you make that line through it, you're actually making 1s all over the place, little flashy 1. Okay? Everyone's like, I don't know what they are. They're 1. So if you something times something times something times something, it'd be just 1 times 1 times 1 times whatever's not crossed off times 1 times 1, right? That's all you're doing. You're actually making a whole bunch of flashy 1s. Okay? So if I actually cross this out, it'd be a 1, and this would be a 1, and 1 over 1 is 1. So that's all you've been doing the whole time. You've just been making little flashy 1. Okay? Now, what makes more work for you guys is if you actually GCF these. You're like, right, 2x plus 5, 2x plus 2. You do that, you're going to have to distribute it back in the next step. So you're like, taking it out, put it back in. Okay? So the only time you actually want to take out GCFs in the numerator is in the very last step to see if there's something you can cancel off. So we only ever GCF for difference of squares of denominator. So in the top here, we have 4x plus 10 minus 2x plus 4 over x plus 3. X times equal negative 3. Right, MPV. And then we can have 4x plus 10 minus 2x minus 4 over x plus 3, which results in 4x minus 2x, which is 2x, positive 10 minus 4 plus 6 over x plus 3. And I can actually take 2 out. X plus 3 over x plus 3. And the only catch is that I have to replace the non-principal values so I cancel, right? Which I already did. Non and equals 2. So, before I move on to the harder adding and subtracting, which is tomorrow, I want to be able to do the basic stuff really well. So we add that extra step where you might have to FOIL and such with x plus 3 and x plus 4, that we're really good at the basic stuff before we add the hard stuff. So, your homework. Draw a lot. Page 249. Numbers 180. 3 and 4.